discussing about work, heat, and the rest of thermodynamics. Before that, subscribe, share, and like our video. Let's continue the topic. Work, heat, and the rest of thermodynamics from grade 12. From grade 12. Before we see first law of thermodynamics, let's see two terms: what system is and surrounding is. First, what is a system? A system is a behavior of definite group of molecules. It is a behavior of definite group of molecules, and it is our subject of study. It is subject of study, and a system, it may be solid, can be solid, liquid, or it can be gas. Also, we may have a simple system and a complex system. Therefore, a system can be simple or a complex. Whereas the second term discussing here is surrounding. A surrounding is an environment around a system, and it is in thermal contact with the system. In thermal contact with a system. For example, if we take a particle in a box, then there is a particle inside a box. It is the system, and the box that surrounds a particle is surrounding. Or if we take a glass of water, there is a glass of water. A glass is taken as a surrounding, and water in a glass is taken as a system. Therefore, a system, it can be a liquid, it can be a solid, or if we take a gas in a balloon, if we want to study about the behavior of a gas in a balloon, the gas is taken as a system, and a balloon, here it is taken as a surrounding. Now we are introducing two terms, system and surrounding. Before we go to first law of thermodynamics, the next basic term is a work. So, what is thermodynamic work? And the second term discussing here is thermodynamic work. Then, to see our thermodynamic work done, let's take a piston of gas. There is a confined gas here. When we exert force on a piston. We are applying force on a piston. When we are applying a force on it, there is a displacement in the direction of a force. There is a displacement from x naught to x final, which is a displacement delta x. And in science, work is done when a force applied on a body, and if there is a displacement in the direction of a force, then there is a work done. This work done is given by work equals force multiplied by a distance delta x. When there is a force inside a piston, there is a pressure, and this pressure is given by, from mechanics, pressure P is equal to force acting per unit area. And this implies that force F is equal to pressure multiplied by area. When we substitute instead of force, pressure and area, we get what? Force. Delta force means pressure multiplied by area times delta x, and base area multiplied by height, which is volume, then work done equals pressure times change in volume. Because this product, area, base area multiplied by height, which is volume, therefore work done is equal to pressure times change in volume. Therefore, in thermodynamics, work is done if there is a change in volume. Work if volume constant, then work then becomes zero. This is the second basic concept to state first law of thermodynamics. Before we see a system and surrounding, now the second topic, thermodynamic work done, and the third basic term is the internal energy. So what is internal energy? Internal energy is internal energy, which is denoted by change in U. It is the sum total of a potential energy and a kinetic energy. It is the sum of a potential energy and kinetic energy of a given system. There is a system and surrounding there is an internal energy of a system. The sum total of a potential energy and kinetic energy of a given system. First law of thermodynamics. First law of thermodynamics. It is the consequence of law of conservation of energy, which is energy neither created nor destroyed, but transfer from one form of energy to the other form of energy. First law of thermodynamics. It is the consequence of law of conservation of energy, law of conservation of energy, based on law of conservation of energy. First law of thermodynamics relate three variables. It relate the internal energy of a given system, heat energy absorbed or extracted from a system, and work done on or by a system. Hence, first law can be stated as, if we take a system and surrounding, there is a system which is changing U, and there is a work done on a system, changing work done. Also, if we give heat into a system from the surrounding, there is a change in Q, energy in the form of heat and work done on a system. This will increase the internal energy of a system. Therefore, we can write the increase in the internal energy, change in U, equals energy entering to a system through heating and work done on a system. This is what we call first law of thermodynamics, and it is stated as the increase in the internal energy of a system, the internal energy of a given system is equal to the sum of energy entering to a system through heating, energy entering to a system in the form of heat through heating, and work done on a system, This is first law of thermodynamics. Here there is a convention. From this statement, if work is done on a system, it becomes positive. It is positive. And if work is done by a system on a surrounding, work done is negative. This is our convention from this statement. If work is done by a system on a surrounding, so what's the form of first law of thermodynamics? From first law of thermodynamics, the increase in the internal energy equals energy entering to a system through heating and work done on a system. If work is done by a system, then we can write this as increase in the internal energy equals energy entering to a system's rating and work done by a system. If work is done by a system, this becomes a minus, and rearrange it. When we rearrange it, we get change in Q equals the increase in the internal energy plus work done by a system. Both forms is first law of thermodynamics. Both equations are first law of thermodynamics. Both are the consequence of law of conservation of energy. It relates internal energy, energy entering to a system's rating, and work done on or by a system. This is what we call first law of thermodynamics. Now, let's see first law of thermodynamics for different thermodynamic processes. First law of thermodynamics for the first one, for isothermal process. For isothermal process, iso means equal, thermal temperature. If temperature constant, while pressure and volume varies, such process is isothermal process. If temperature constant, keeping temperature constant, there is a relationship between a pressure and volume, and this is P1 V1 is equal to P2 V2. This is what we call a boyles law. Boyles law. Hence, for isothermal process, the increase in the internal energy becomes 0 because temperature constant. In this case, change in U equals 0. Therefore, first law of thermodynamics can be written as the increase in the internal energy, equals energy entering to a system's rating and work done on or by a system. But since temperature constant, increase in the internal energy becomes 0. When we shift to the left heat energy, it becomes a minus. Then minus of change in Q equals change in work done. This is first law of thermodynamics for isothermal process. Next, for isobaric process. Second, for isobaric process, iso means equal, baric pressure. In this case, pressure constant, while volume and temperature varies. The relation were studied by Charles Law and it's given by V1 over T1 equals V2 over T2. This is Charles' law. For isobaric process, work is done by a system. For isobaric process, work is done by a system. Therefore, first law, increase in the internal energy equals energy entering to a system through heating and work done by a system. If work is done by the system, this becomes minus, and thermodynamic work done is given by pressure times change in volume. This is first law of thermodynamics for isobaric process. And the third one, isochoric or isovolumetric process. Isochoric or isovolumetric process. Isovolumetric process, and in this case volume constant. If volume constant while pressure and temperature varies, These were studied by Gaylussacs law as follows: P1 over T1 equals P2 over T2. This is Gaylussacs law. And for isochoric process, first law written as the increase in the internal energy equals energy entering to a system through heating and work done on a system. If volume constant, then work done becomes 0. Therefore, energy entering to a system through heating and internal energy becomes equal, and changing Q equals mass times specific heat capacity times change in temperature. This is first law of thermodynamics for isovolumetric process. The fourth process is adiabatic process. For adiabatic process, what will be the first law of thermodynamics? Adiabatic process, it is a process such if no heat energy flows into or out of a system, such process is adiabatic process. For adiabatic process, there is no change in heat energy. Changing Q becomes 0. Therefore, first law can be written as increase in the internal energy equals work done on a system. This is first law of thermodynamics for adiabatic process. Finally, if we see the graph of pressure and volume axis, then the vertical line represents isovolumetric process. Vertical line, it represents isovolumetric process because in this case volume remains constant. This is isovolumetric process. And the horizontal line represents isobaric process. And there is two curves which represent isothermal process and adiabatic process. So this one is adiabatic process, and this one is isothermal process. The area under pressure versus volume graph. The area under pressure versus volume graph gives a work done. This is what you have for today. Next, we'll see examples related on first law of thermodynamics